SWaP-C2 is an acronym for size, weight, and power, cost, and cooling. You may wonder why the A is before P and not SWaP-C2. It's due to the fact that initially the acronym was SWaP, size, weight, and power. They quickly found that products developed trying to optimize size, weight, and power were quite unsellable given their costs. So cost was quickly added. Recently, the defense industry has added cooling. As power increases, the need for cooling those CPU and power supplies has become quite relevant. The industries that utilize SWaP-C2 are aerospace, defense systems, and government contracts. SWaP-C2 is challenging, but what I think is the coolest function of it is trying to balance all 5 of these factors when developing a device, a system, or a program. SWaP-C2 is kind of like a 5-legged stool. As you try to optimize to balance the size, the weight, power, the cost, and the cooling, this 5-legged stool won't stand if they aren't in balance. You might be able to get 3 of the 5 balanced to have a stable system, but the best and most efficient and most optimized would have the ability to design a system or a device that balances all 5. When optimizing for SWaP-C2, you start with trying to minimize the size and weight of a product, but keeping in mind to integrate in the power and cost aspect or factors as well. Cooling ends up being more of a side effect of what's needed as more and more power is included within the device or the system. The ability to cool that power becomes paramount. Using SWaP-C2 to design a product starts with defining what the requirements of that product need to be. What are their features? What is the customer or the client's? What are the specifications? Part of that will be defining the size or the weight or a combination of that for the final product. Then becomes the challenge to find devices, define electronics that fit within that size and weight budget. Power usually comes from either the power supplies or the computer system. How much compute power does this product need to be able to support? And last is the cooling. As power increases, the ability to perform a CPU at its peak power, then heat needs to be dissipated and a cooling system becomes paramount in delivering an efficient SWaP-C2 product. Sealevel is using SWaP-C2 techniques in their design due to many of the products requiring large amount of CPU power. Sealevel has had to develop custom enclosures with integrated heat sinks and custom coating to help dissipate the power within the module being developed. My favorite challenge in designing with SWaP-C2 techniques or in mind is just the ability to balance all 5 factors as best as one can. I used to do a lot of development and didn't consider SWaP-C2. Although the products worked well, they didn't meet the end customer's requirements, and thus redesign typically had to be done to make the product meet all 5 of these factors as best we can. SWaP-C2 I see moving forward in not just aerospace and defense, but in other industries as challenges to integrate more powerful CPUs, higher current capacity power supplies. As we move into these other industries, then SWaP-C squared, keeping everything, cost, the ability to cool, the added power, the size, the weight. It's just going to be a challenge for all design engineers moving forward in the future.